Let's go through code 785 is graph bipartite. So it gives us an integer, two-dimensional integer array graph. It uses um, the two-dimensional array means this one means 0 is connected to node 1, 2, 3. And it asks whether this graph is bipartite. So a graph is bipartite is if the node can be partitioned into two independent set of A and B. Then every edge in that graph connects a node in set A and a node in set B. So what that it means is that if there is an edge, right? So for example, this will be A and then this will be B, right? So if there is edge, those kind of nodes just uh, connect by this edge. They should have different into different set. Or we'll say color, right? If this is red, then this will be a blue, right? This is false because if this one is red, we need to get this one as blue, right? But this one, there is another edge. So we cannot have these two be here, right? And the second one is true. For example, we set this one as red, this as blue, this as red, this blue, right? So for this question, we can use just trying to see if those kind of nodes can be into um, to partition into two sets, right? Or we'll say we're color these kind of nodes, one into a blue color, one to a red color, right? So what we do is that we can use DFS, right? DFS to have a color array. For example, we use one to represent a red color, minus one represent a blue color. So we from any nodes which is not colored, we just do DFS right to the next node to its next. For example, current is one, then set it next as minus one. And until we DFS finish, if we didn't have a conflict, right? For example, this is one. We didn't get a conflict, we return true. Otherwise, we return false. So we can write code for this, right? So we're going to int n equals graph dot length, and we use a color array equals new int n. So for int I equals to 0, I smaller than n, I plus plus. Or let me say if this is already colored, right? Color I down equal to 0, we continue. And our DFS will return a true or false. So we'll say if DFS graph, we need a graph, and I this current node, and let's say current color. If it's not colored, we set this as one, right? And color array. If any of this return false, we just return false. Means this is not able to be bipartite. Otherwise, return true, right? And private boolean BFS. So what we do is that we need to pass in the graph, and we need a current node, right? And we need a current color, and we need the color array, right? So what is the exit condition for this DFS? Is that if current color, this current node is already colored, right? Without equal to 0, we return color current equals current color, right? Otherwise, that means this current node is zero, right? It's zero. Then we need to set this as our current color. So have color current equals C C O L R. Then for its next, right? For current. So if any of this is false, for example, DFS graph. So it's next, right? So for its next, we use its color should be changed uh, because it is there is a edge connected, right? So if originally it is one, now it is set at -1. If so, originally it is C current color, so it was set as C color, right? In the color. If any of this is return false, we just return false. Otherwise, we return true, right? And we also can write a Python code for this. Um, we need a color array, so we need its length to be graph, and we are going to have color equals this one multiplied n, right? So so what we do is that we need to define a DFS, right? Current C C O R O R, and this one return mm, return hello. So what do we need is that if this color current it's not there means it's already been lit before, right? So that is already colored before. So we need to make sure this color current equals C C O L R. Otherwise means this is not visited yet. We just set color current equals C C O L R, right? And so for next node or child, right? Any child in graph current. If not DFS child, and we'll set up C C color, we return false, right? That means if current color is 1, we will change to -1. If the current one is -1, I change to 1. Otherwise, we just return true, right? So in our main function is that we're going to have for I in range n. If color I equals 0, um, and not DFS I1, right? We just return false. If we go through all of this, we just return true. If not, this is the CC color. So we know we have a DFS function here, right? So every node for the DFS is at most visited one time, and for the edge, it is at most visited twice. So the DFS has O n plus E time complexity, right? And so we in this outer loop there is a n operation, right? But the thing is that this one, even this is n, right? But every node is just going to visit only once. So every node is going to just be DFS only once. So the time complexity is still O n plus E, right? And the space is O n space complexity.